Hello everyone. Today is the first video of what's going to be a series of videos on the subject oceanography. I would try to introduce this subject to you to whichever extent I can. I would try to cover the physical oceanography and chemical oceanography and hopefully some biological oceanography. And this is for introductory purpose, I could say. I mean, it would cover your academics and some of exams like JRF and any other exam that has oceanography as subject. But I request you to read from books. Don't take my words as final because I am a student and it's imperative that I will make mistakes. So yeah, let's start. So the first lecture that uh, I have planned for today is I would talk about marine provinces, basically what features that we get in our oceans, I mean ocean floor, and also whatever I would be talking about is taken from this book. I mean almost all of it. It is an excellent book for introduction to this subject, and if you go through it, it would be most definitely helpful. So yeah, this is a summary of the terms that we would be encountering in this unit. I would break this unit into few parts. For like today, I have thought of introducing the techniques that we use for measuring the features, I mean recognizing features on ocean floor, and yeah, subsequently I would introduce these different features to you for like what features do we get in shallow regions and what do we get in deep ocean basins. So yeah, let's start. Okay, so what techniques are used to determine ocean bathymetry? So like it is sort of a conventional technique. Echo sounding, it's exactly what it sounds like. We use sound waves to recognize the features on the ocean floor. We send sound waves from the ship, they bounce back, come back to us, and they get recorded. So using this their travel time, we decipher the objects that we encounter. For example, like whether the relief is high and low, and then we can use it to make maps like these different colors represent different height. And then we have precision depth recorder. Again, it's the same technique, just it's more precise. So like it has a resolution of about 1 meter, so it's better in terms of resolution. Okay, so then we have modern acoustic instruments like multi-beam echo sounder and side scan sonar. So multi-beam echo sounder is again based on the same principle. It's just that we use multiple beams in one go. So like you can see here, like we have sent multiple beams and then they bounce back. Again, the principle is the same. And then we have side scan sonar. Side scan sonar is basically we tow our instrument behind the ship, like here the ship is our ship is here, and then it scans the ocean floor. And it's called side scan because it's like if you can see, this is data gap, so it doesn't record the data right under it at perpendicular, but it records whatever is at a slight angle, so it's called side scan sonar. So this is an interesting one. We use satellites to map the deep ocean floor, I mean any ocean floor, but like even deep ocean floor. So how is it possible for a satellite that is way up in our atmosphere, and it can recognize whatever feature we encounter in even deep ocean floor, and it has the highest resolution. Yeah, so it has an accuracy of 4 centimeter, which is phenomenal. So like the ocean floor is filled with water, right, and it's still able to mimic the ocean floor almost perfectly. So how does it do that? So there is this concept of gravity anomaly. So I'll try to explain what gravity anomaly is. Gravity anomaly is basically the deviation from an expected gravity value. So like we know that at different latitudes we have different gravity values, and it also varies with height and everything. So we have calculated certain gravity values for reference. So if the our gravity value is above or below what is expected, then we call it as gravity anomaly. So like I'll try to explain it in the next slide. Okay, so this is a map of the observed gravity anomalies over the Earth's surface, and so you can you can see the blue regions correspond to negative gravity anomaly, and the red, yellow and whitish regions correspond to positive gravity anomaly. So wherever there is excess mass, we will have positive gravity anomaly, because more mass means more attraction, and wherever we have low mass, we will expect low gravity values, so negative gravity anomaly. So we know that ocean trenches have very low mass. They are basically almost empty, so we expect the gravity values to be low there. So as you can see, this is a subduction zone, and here you can see the blue region is corresponding to low gravity anomalies. And whereas if we see at mid-oceanic ridges, we know that the magma just keeps coming out, and it creates mid-oceanic ridges. They are thousands of kilometers long, so they have more mass, so they correspond to positive gravity anomaly, as you can see in this region and other regions as well. Wherever there is mid-oceanic ridge, there would be positive gravity anomaly. So the water surface, this is the important point that answers the question. Water surface above the ocean mimics the whatever features that are present on the ocean floor. So if we have higher relief, the water would be higher there on the surface, water surface would be higher, and if we have low relief, the water surface would go down a bit. So you can see in this slide, this one, see here, the ocean floor is a bit higher. Yeah, so here the ocean floor is higher, and we have higher water surface. The ocean floor is lower, and the water surface is also lower. So this is the methodology that it uses, and you can see the contrast in the detailing of the ocean floor map using two different ways. This is using the ships, I mean the techniques that we talked about earlier, the side scan sonar and everything, and this is how a satellite maps it. So you can see the detailing is like very much accurate, I mean much better. And this is another method that uses seismic reflection profiles, and so it's very similar to the sound techniques that we talked about earlier, and we send low frequency sounds, they reflect back, and then they are recorded, so we can use this to map the ocean floor. Okay, so this is it for the today's video, and in the next video I would talk about I would start with the features that we find in different oceanic regions. For example, we have continental margins, shallow water areas, then we have deep ocean basins, then we have mid-oceanic ridges. So whatever features that we encounter here, I would talk about it in subsequent videos. Like maybe I would break it down into different videos. So yeah, that's it for today. If you want the this slide, you could text me. I have provided my Instagram, LinkedIn, Twitter, and yeah, you could text me there, and I would send it to you, hopefully once it's completed, because it's I have only made few slides, and yeah, that's about it. And it would mean a lot to me if you could subscribe the channel, if you think you have gained anything, or if you want to continue watching these videos, because it would keep me motivated to keep making the videos. And yeah, thank you.